Alrighty guys, this is the second video that I'm requiring you to watch for our spring break assignment. You should have just spent some time refreshing on the unit circle. It's going to be very important that you have that memorized, especially if you're going to memorize anything, it's going to be the quadrant 1 of the unit circle. And so we're going to use the unit circle to evaluate trig functions. But before we evaluate any of our trig functions, let's do a quick refresher on what these 6 primary trig functions are. So if you remember the first 3 here, sine, cosine, tan, right? They all represent a relationship between the angles in a right triangle, right? And so you may have seen this word, SOHCAHTOA, right? And in order to apply SOHCAHTOA, you need to have a reference angle, okay? There has to be some angle you are looking from, right, to reference. So theta, again, is used to represent an angle. Anything you put inside of a sine, cosine, tan, cosecant, secant, or cotangent function will always be an angle. Okay, that's what goes inside of here is an angle. So for trig functions, right, your input or your independent variable is an angle, okay, theta. That means that your output, and this will come up over time, will be a ratio of sides. Okay, so just like you have y equals, for example, sine of x, your input should be an angle. What comes out of your sine function should be a ratio of sides. Okay. All right. So looking here, we have, from this angle's perspective, right, we've got a side opposite and a side adjacent. Okay. This will always be the hypotenuse. The hypotenuse is always located across from the right angle, right? So we're just going to refresh our memory here. Sine is opposite. Sine of theta is opposite divided by hypotenuse. So I'm going to write opposite divided by hypotenuse, okay? Cosine of theta is going to be adjacent, so adjacent over hypotenuse. And tangent of theta is going to be opposite divided by adjacent. Okay. All right, now the cosecant, secant, cotangent. These are reciprocal trig functions, okay? All this means is, literally of these 3 primary ones, the solutions here, the answers, these are just the reciprocal, okay? So cosecant is paired with sine. So instead of it being cosecant of theta, instead of being op over hypotenuse, it's hypotenuse over the opposite side, okay? Secant of theta is paired with cosine. Instead of it being adjacent over hypotenuse, it's hypotenuse divided by adjacent, okay? And then the last one here, cotangent's paired with tan, and it is adjacent divided by opposite. Now, we're not actually going to spend time using these trig functions in the context of a right triangle. That's something you should have probably learned in Math 2 and Math 3. But we are going to look at how we can relate these trig functions to the unit circle, okay? And so, again, you should have refreshed on the unit circle in the video before, but if we take a look at one right here, there's some very, very important information on this unit circle, okay? The first thing to notice here is we recognize that the unit circle goes in this direction, right? We've got all these angles. They're in degrees and they're also in radians. Now, if you notice here, if you were to take, say, this coordinate point on the unit circle, or this coordinate point, right? This is a coordinate point 1, 0, right? Now, if you were to just drop this coordinate point, drop a perpendicular line down, what you see is what we've created here, right? We've created a right triangle, okay? Where this right here is our angle, our 30 degrees, or our pi over 6. So this is really our theta, okay? I'm not going to go through the proof, but essentially, this coordinate point, this is an x value, this is a y value, correct? You can derive these from this x distance right here and this vertical y distance, okay? And the way that these are derived is through SOHCAHTOA, right? Opposite over adjacent will give you 1/2, or opposite will give you your root 3 over 2. Opposite, let's say, no, that will give you tan, but opposite hypotenuse, that will give you your sine, right? And you can go on and prove it. But what I care about, I'm not going to actually go ahead and prove it, but the key takeaway here is to recognize that your x comma y coordinate is in fact sine of whatever angle you're at, cosine of whatever angle you're at, and sine of whatever angle you're at. And that's what this piece right here is telling you, okay? What that's saying is, if I were to ask you what cosine of 30 degrees actually is, so this is asking you to evaluate cosine at 30 degrees, okay? All you need to do, and this is why people memorize the unit circle and it's so helpful to have, is all you need to do is remember, okay, the x coordinate is associated with cosine, okay? The x coordinate is associated with cosine. So looking at all the x values here, this is all a ratio of sides, okay? These are sides, a ratio of sides, okay? You know what? Why don't we actually go through one example? So if I'm going to redraw this triangle off to the side here, so you can see what I mean by a ratio of sides, okay? We know that theta here is going to be 30 degrees, right? Okay. Now, this distance here, we're not sure of, right? Because 1 is all the way, so we don't know what this is, but it's some x value, so x, right? And this distance here, again, we're not sure, but it's some y value, right? And this distance, well, that's here. That's actually the radius of the circle, which we do know to be 1. Okay. So if I wanted to find, say, cosine of 30 degrees, right? Thinking about SOHCAHTOA. Okay. Cosine is adjacent hypotenuse. So from 30 degrees angle, it's adjacent x divided by hypotenuse 1. Okay. Now, when you actually calculate on your calculator, okay, I don't know if you guys can see this. Make sure that your mode here, if you hit mode, make sure it's in whatever angle measure you're working in, so degrees, right? We can calculate cosine of 30 degrees. And so this is 0.866666, right? 0.866 equals x over 1. And if I wanted to actually go ahead and solve for that x, I would just get x equals about an estimate 0.866. Okay. Now, that doesn't really mean anything to you, but if you look over here, root 3 over 2 is our x value. Now, you'll notice, watch what happens. Wait, let me keep the cosine of 30. If I take the square root of 3 divided by 2, do you see how it's the exact same number? So really, this equals exactly the square root of 3 over 2. And that's what I mean by a ratio of sides. So all of these coordinate points are ratios of sides that come out of this relationship here. And so I can do it again with sine of 30 degrees. But I bet you anything I'm going to get 1/2. Okay, so let's see. Sine of 30 equals its opposite hypotenuse, so y divided by 1. And sine of 30, and there we are. Sine of 30, in fact, equals 1/2. And over 1, so you can just ignore that, right? All right. So we'd agree cosine of 30 is just this ratio of sides. That's the output, right? Root 3 over 2. Okay. And now you can actually do this for every single trig function. It doesn't just have to be sine and cosine, okay? because if you go back here, right, tangent isn't just opposite adjacent, okay? So these definitions actually aren't going to be that helpful for us when we're using the unit circle, okay? What might be more helpful is to know that, well, okay, sure, it equals opposite hypotenuse, but in the context of the unit circle, we're thinking about x comma y. Well, we know it equals the y values on the unit circle, right? We know that. That's what we did here, okay? Sine is the y values. Sine of whatever angle you're dealing with, okay? Cosine are the x values. And then you may or may not have known this identity, but this goes back to your trig identities. Tangent of theta is the exact same thing as sine of theta divided by cosine of theta. So when we're thinking about using the unit circle, sure, it equals opposite adjacent, but it also equals sine divided by cosine, which is also y divided by x. Okay? And then if we want to put, again, formulas for these reciprocal trig functions in terms of the unit circle, so it's more useful, it's just the reciprocal of each of these. So this is over 1, right? Which means that cosecant of theta is going to be 1 divided by y, because it's paired with sine. This is going to be 1 divided by x. And this, we just flip both of them. It'll be x divided by y, okay? So really, we want to kind of not forget, but just not use these definitions. These aren't really useful for us in the unit circle, okay? It's these ones that we're going to focus on moving forward. All right, so I'm going to pause and start a new video for the next few example problems.